The title of this talk in the conference materials is Pglogical, but I wanted to talk a bit more broadly about logical replication with the focus on Pglogical, so that's why the title is a bit different in the actual presentation. I will give the people a couple of seconds to sit down. Okay, so as Harald already said, I work at Second Quadrant as Postgres developer consultant, and I do support as well. I've been Postgres contributor for a long time. I also maintain PG Bouncer with Marco Kren, and I'm also a major contributor to another replication solutions like BDR and Lundiste. And you can write me on petr@secondquadrant.com or find me at GitHub, LinkedIn, and wherever. I will start with a bit of history about the replication in Postgres, and then move on to actual Pglogical in detail. Originally, in version of like PostgreSQL 7.0 around the 2000, the general thinking in Postgres core community was that replication should be actually handled as external project and shouldn't be part of the core Postgres at all. Obviously, the users and the market eventually changed, so the community came to conclusion that we actually need a replication that's easy to set up inside the core itself. The first big step towards that was in PostgreSQL 8.0, where point-in-time recovery was introduced, and that was actually written by Simon Ricks, who had the previous presentation here. That enables you basically to do write-ahead look archiving and then restoring to specific point in time from that. The next big step was Postgres 9.0, where the streaming replication, the physical replication, was introduced, and that basically enables you to do standard replication via sending bits of changes in the actual files over the network stream and applying them on the standby, which is then exact copy of the primary. The next big step in the replication development was implementation of logical decoding in 9.4. Valentin was talking a bit about that in his keynote. They are using it for the data integration, but the main and the original purpose of that was actually to enable logical replication. History of logical replication is actually much older than the logical decoding, though, because technologies like Sloany and Lundiste emerged in early 2000s. They were basically the result of the aforementioned philosophy of the core product that the replication should be something that's handled externally. They have several disadvantages over the in-core replication, namely that they run completely outside of Postgres, which means that you have to monitor something again separately, that the process is running, everything is okay. You can't monitor it from within Postgres with simple SQL queries like you can do with the physical streaming replication. They use tables as queue, which means that everything is written to both the normal table and then to the queue table, which means that there is much more load on the provider side or on the upstream node. And of course, because there is no way to directly map the commit order to the writes into the table, or no easy one, they actually have to have a relatively complex code to achieve the consistency on the replica with the master. They have to do complex calculations to actually achieve a commit order that is same on both sides. What we did when we've seen this situation, and we thought that Postgres actually could use logical replication in core as well as it has the physical one. So we started something that we call BDR project. which goal was to provide native logical replication which doesn't have these downsides of running outside, having separate configurations outside, having to use tables and amplifying writes. Originally, that was designed, again, by Simon mostly in 2011, prototyped by some of my colleagues in 2012. As a result of these projects, actually, a lot of the patches came to Postgres, namely logical decoding or event triggers, commit timestamp tracking, even the extensions were partially part of this development. Obviously, this project is running outside of the core Postgres. We use it as kind of a vehicle to develop the logical replication itself, and so it's not yet fully integrated into Postgres. The current state of that project is that it was split into two separate subprojects. One is the BDR, which provides multi-master with transparent DDL, with distributed sequences and stuff like that. It requires modified Postgres and only runs on 9.4 at the moment. And then we created Pglogical, which is basically something that should eventually replace the Londist, Slony, and other trigger-based solutions. It works on vanilla Postgres 9.4. It's just extension, provides one-way replication, and eventual goal of all this is basically to get some logical replication into PostgreSQL core available out of the box. So a bit of the technical stuff, how things work. So the normal physical streaming replication works somewhat like this. You have applications communicating with parser and executor. They read from the data and write to the data and also write to the write-ahead log. The changes that are written to write-ahead log are then read by a process which we call val sender, because it's sending val to the standby, where val receiver writes again to the write-ahead log, from which the data goes to the main heap, and the applications can actually read from that. They obviously can't write, because, as I said, these changes are binary changes of the underlying files, which means that you can't actually change something there and still apply the binary diffs in a way that it would work. So if you would write on the standby, then that would obviously corrupt the whole database. The logical streaming replication builds on this. It introduces the logical decoding that basically inside the val sender decodes the write-ahead log stream into series of logical changes, meaning that row with these values was inserted into table such and such, row with these values was updated in the table such and such, and those are then sent via low-level CE API to the plugin that can then decode them to whatever protocol it wants and do whatever it wants with them. So Zalando, as was said in the keynote, uses that for extracting events from the database, but we are using the same mechanism for actual replication. On the other side, instead of the val receiver, there is apply process that basically gets the data and just executes the updates and inserts and deletes on that local database. As a result of this, the databases are not completely the same. The subscriber side is actually writable. Obviously, there can be conflicts between what you write on the subscriber and the provider, and so the replication actually has to handle these conflicts. Pglogical actually provides a way to resolve those. That's configurable. It's documented. I will not repeat the manual because this is actually quite extensively documented. So Pglogical, basically what it is, it's the output plugin on the side of the provider, plus some more logic on top of that. It's the protocol itself, and then the whole apply side, which handles the actual replication. So what's the point of actual logical replication here? Well, as I said, the physical replication is exact bit copy, meaning that you have to replicate your whole instance You can't select just some tables or some databases. You can't create additional tables, indexes, nothing like that. So, and also since Postgres data or write-ahead log format is not forward compatible, you can't replicate between different versions of Postgres. So the logical replication basically solves all these issues. It allows you to create temp tables, but actually even normal tables or unlocked tables, whatever you want on the standby. It allows you to define completely different indexes. For example, if you are running some analytic queries on your replica, then you can add additional indexes without having to amplify writes on the original OLTP database. And you can also define different roles and different security for the objects in the database. The way that we implement it also allows some limited data transformations, which we want to eventually expand as well. And obviously, since it knows actually more about the changes that happened, it can actually replicate just part of the database. It doesn't have to replicate everything. And it works cross-version. So one of the goals of the Pglogical is actually to provide online upgrade as well, which means that you can, if you have 9.4 or higher and want to upgrade to newer version of the major version of Postgres, then you can spin up a new database with that version and just replicate your existing data, and then once it's actually codes up, you can repoint the application to this new running server and have upgrade without having to have any specific long downtime. The downtime in this, especially if you combine it with something like PG bouncer, which can reroute your connections, can be really just a hiccup from the point of the application, depending on how slow your queries are. The other use cases that are quite important for us is data transport, like generic data transport for various reasons, like integrating data from multiple databases into single target database, streaming changes to analytical databases, or having one single master configuration database for multiple actual data storages. So you basically, I will actually show you some example setup and explain what I mean with that. And also, one thing that's actually achieved by using the same mechanism as the streaming replication, which you can't do with all those trigger-based solutions, is that Pglogical can actually provide you synchronous replication the same way that the physical replication does. And so, for example, now in 9.6 we have the multiple slaves support. So that will work transparently with Pglogical out of the box without us having to do any changes, because we actually use the exactly same mechanism as the physical replication for that. Some more details into this, how we achieved some of that. So Pglogical actually installs this extension, which means that there is no external daemon running outside of Postgres. It's all, when the Postgres is started up, it will automatically start up. When the Postgres is shut down, it's automatically shut down. All the configuration is inside the database, so you don't have to keep any separate configuration files outside of your database. As I said, it uses the logical decoding to read the write-ahead log. So that allows us to have like really small overload or overhead on the provider, because we just read the changes as they happen in the write-ahead log and don't have to write anything to separate meta tables or queues or anything like that. And we also don't have to solve the commit order issues, because the write-ahead log already has the commit order information, so we just read it from there. And one recent change that we did in 1.1 was that we enabled triggers, so that we actually execute the triggers on subscriber, but only if they are set as enable replica. Normal triggers are not executed, only the replica triggers are executed. So that enables you to do some additional operations on the replicated data as they come in, for example, updating some counters or aggregation data and stuff like that. So installation, or the whole setup, The basic setup is quite simple. You just install the extension via normal create extension command. On each provider and subscriber, you have to create the node, which you have to name. The name should be unique. And then you have to provide connection string to that node that you are creating. So this connection string is for the my provider. This connection string is for the subscriber. And then you create subscription where on the subscriber, which you again name. The name is actually important for monitoring and for the synchronous replication, because this is the name that you will see as an application name of that replication. So when you check, for example, pgstat activity or pgstat replication, this is what you will see there. It's also what you specify if you want to do the synchronized standby names. You again use this name for that. And the host from which it should start replicating, which is basically the provider. It copies the information about the provider node from there and starts replicating. There are actually more parameters to this. There is optionally synchronization of the data or synchronization, like initial synchronization of the data and initial synchronization of the schema. And some additional options that I will not go into because it's all documented in the README, so I don't want to talk about what's in the manual too much. So how the replication actually works is that the tables are split into groups, which we call replication sets, which is very similar to what in Slony is as a replication set. They need to be defined separately on each provider. The definition of the replication sets is not replicated currently. The main reason for that is so that we can easily replicate from multiple upstreams to single downstream without having conflicts in the replication sets. No table is actually replicated until you add it to the replication set. And if you define some overlapping replication sets where you have multiple tables in one and the subscription actually subscribes to multiple of them, you will only always get the change for each table once. There will never be duplicate changes sent. The additional stuff that you can do is actually filter by action, which currently that means insert, update, delete, or truncate. So you can say if the individual replication sets are actually replicating these actions or not. By default, they replicate all the actions, but that can be changed. That's useful, and we actually have this in production, very useful thing for warehousing, for example, where you don't replicate for some historical tables or time series tables, you don't replicate deletes and truncates, and just remove the old data from the transactional database, but don't remove them, but they will not be removed from your data warehouse automatically. There are some predefined replication sets that you can use. The default is the default one, obviously, that replicates everything. Then there is default insert only that basically replicates inserts and truncates. The reason why this replication set exists as a predefined replication set is that in order to replicate updates and deletes, we require you to have a primary key on the table, so that we can actually do lookups of the rows that were updated and deleted using something that's unique without having to do sequential scan every time you change one row. So if the replication set actually replicates updates and deletes, the table that doesn't have primary key will not be allowed to be added for that. So for that purpose, we have this replication set default insert only, where you can add any table even if it doesn't have a primary key, but only inserts and truncates will be replicated for that table. And then there is DDL SQL. I will explain that one in a bit later. So how do you replicate table? It's very simple. You just call the function replication set add table, where you specify the name of the replication set and the name of the table. This can actually be even OID of the table. It doesn't have to be the name. So you can do join on PG class or PG tables system catalog and do multiple table additions in one query using join. And you also optionally specify if the data can be, should be synchronized at the time of the table being added. If you say this as a false, then only the changes will be sent, but not the initial data. The data resynchronization can happen at any time. There is the function that you call on the subscriber, actually, alter subscription resynchronize table, that will basically make new copy of the table data. The one thing to note about this is that it will actually truncate the existing data and then copy the new ones. Currently, we don't support automatic synchronization of the structure yet. Sequences work very similar. You just add them to replication set as well. Just the function name is different. You just call it with add sequence instead of add table. The replication itself works quite differently though, because Postgres logical decoding actually doesn't support any kind of decoding of the sequence updates. And also, even if it did, the updates of sequences, like sending them over network, would be quite expensive for the performance. So what we do instead is that we replicate them periodically in bulk. So we basically check once in a while, which how long it takes between the checks is actually dynamic based on the load on the server. We check once in a while what sequences changed and send the values over. This would obviously normally mean that the subscriber would be always behind of the provider. But so to not be behind, what we use is a dynamic buffer of the last value. So for example, the buffer is actually dynamic, so it can change somewhere between 1,000 and 1 million values, depending again on how often the sequence is updated. So for example, if you create new sequence and that has value of 1, the first value on the subscriber will be 1001 instead. This basically makes sure that the subscriber never falls behind of the provider. Obviously, that will not be true if, for example, you lose the replication connection, then the subscriber can fall behind, but that can happen in any replication solution at that point. It's actually inspired by Londiste, which uses very similar mechanism, except Londiste actually has like fixed times when it sends and also fixed buffer. We try to be more dynamic based on like how often the sequences are updated. DDL replication is another topic of bit of pain, I would say. The initial, you can, as I said, in the subscription, you can actually say if the schema will be synchronized or not when you are creating the subscription. The one caveat there is that it's either fully synchronized or not at all. So, which means that it doesn't actually obey the replication sets, meaning that the initial schema copy will be exact same copy of the provider no matter what replication sets you pick. This is mainly because of the low-level technology reasons where we actually use pgdump and pgrestore internally for the schema, and which doesn't provide really good API to filter this. This is something to work on in the future. The DDL is also not replicated automatically. What we provide is interface which just accepts the DDL as a string. It can be multiple commands as well, so you can basically put or copy-paste the whole file that you want to execute into a single call of this function, and it will execute it on all nodes, or actually on all nodes that are subscribed to the replication sets that you specify. Here is where the DDL SQL predefined replication set comes into play, because it's the default value for this parameter, basically. So if you don't specify the replication sets, the DDL command will be sent with this replication set. The reason why we actually support specifying replication sets here is that you might have some subscribers that are missing the tables that you are altering, for example, and so those should not be subscribed to the replication set where this is being executed. Because obviously the replication would fail on those, because when you execute the alter on something that doesn't exist, it will fail and then the replication will be stuck and you have to remove the replication command from the queue, which is, by the way, possible. So example setup, and this is actually from something that we actually have almost in production now, is that you can have a configuration database where you have some common tables that you then replicate to all your other production databases. so that you don't have to update every time on each database separately. And then, for example, you can have several transactional databases that all feed into one analytics database where you run your analytics. This way you can scale your transactional databases without having to compromise on having all the data for analytics in one place. Also, I have some bit of performance. This was run by my colleague Tomáš Vondra, who is speaking tomorrow. This is standard PG bench. There is a few things to note. One is that we are about 4 times faster than long distance Loni. This is basically a number of clients. Basically, if the primary node can only write this many, then we can't replicate faster, obviously. So Slony holds up until 4 and then falls up, no idea why. But we scale a bit better. The one thing to note about this is that we are slower than the physical replication in this benchmark, but that's partially caused by the fact that this benchmark was run only for a short period of time, like 30 minutes or something, which means that the auto vacuum didn't kick in. And the reason why I'm mentioning it is that when the auto vacuum kicks in, we get actually better performance sometimes than the physical replication, mainly because we actually don't have to replicate the vacuum changes over network while the physical replication has to. For the Pglogical and all the logical replication solutions, the things like create index is just replicated as a create index, but for physical replication, you actually have to stream all the data for that index over network, while we don't have to do that. Or if the auto vacuum is running, it's running separately on each server, so you again don't have to replicate all the data over network, so we gain some performance there. Okay, so that was the pretty stuff. Now for some caveat. Big transactions may cause replication lag, mainly because the transactions are sent one by one, as is true for almost every transactional replication system, meaning that if you have one big transaction and then very many small ones, the small ones will have to wait until the big one is replicated, which might take some time. There is also a mechanism to prevent running out of memory when processing those big transactions, so they may actually cause some I/O because they might have to get spilled on the disk so that the replication doesn't take over all your memory. Also, the logical decoding itself, and by extension any replication solution built on top of it, doesn't really play very well with physical replication yet, which means that when the failover scenario, or when you have high availability based on physical replication, then after failover you actually need to resubscribe to the new master because the logical decoding actually doesn't support like following the failover yet. We have patch for that, which didn't get into 9.6 yet, mainly because it was submitted in the last commit fest and we had some worries about the stability. So we plan to get it into next version of Postgres. It's worked on by my colleague Craig Ringer. So hopefully that will be fixed in next version of Postgres. And another noteworthy thing is that all the operations, like the adding of the table to replication and stuff like that, and setting up the replication actually currently require super user privileges. We don't have any granular rights for that yet. Future plans. My current biggest project actually is to write a patch for Postgres based on Pglogical that will get into Postgres itself and provide some basic logical replication. As Simon mentioned in the previous talk, you can't get this feature, like big features in one step, so it will probably provide just the bare minimum that's necessary for something to work. So it might not have all the nice features that Pglogical already has. The plan for that is to have something in the first commit fest of next version of Postgres, so we will see how that goes, and hopefully it will be in next version of Postgres out of the box. But I also plan to continue to develop Pglogical itself, because there will always be features that people want and which will not be wanted by the core community. So my long-term plan is to have basic stuff in core and the advanced stuff as extension. We want to improve the data transformations because the triggers, as I said, we support the triggers on the subscriber, but that's not enough. For example, if you want to transform your data to, let's say, aggregate to some completely different table without writing to the original table when the changes are received, it's very easy to do with insert trigger for inserts, where you basically just do the transformations and write to the different table and then return null, and the replication will not replicate anything, and just write to the different table. But the problem with that is that your update trigger will never be executed because the update never happens because there are no data to update on the original table. So for that, we need to invent some better mechanism so that you can actually do the proper transformations. Because I see stuff like real-time ETL as really good use case for logical replication, personally. So I want to work on this. The other thing that we want to do is filtering by expression. So currently you can filter inserts, updates, and deletes, and truncates. But what I want to eventually be able to do is, say, send only data from this table where user ID equals X, and do that filtering directly inside the replication. One possibility to how to do this might be exactly the data transformation triggers, where you can handle that manually by yourself with simple PGSQL function, but we will see. What I want to also support is push replication, but it's not that big high priority, meaning that the replication would be initiated from the provider and not from the subscriber. As Simon mentioned, the PostgreSQL support is not yet there, so that's another thing that I'm focusing on. And then we eventually want to integrate the BDR features so that the whole BDR multi-master thing can be just extension and instead of patched Postgres. And eventually, hopefully, in Postgres itself, but that will probably take a few years. So now I'm ready for questions. By the way, if you have some questions outside of this, this is the generic email address where to write. Project page with the documentation and stuff is on Second Quadrant website. And we have open source GitHub repository with all the code that's part of the Pglogical. So you are welcome to contribute. So questions? Okay. Harald? Can you give? Okay. Do I have my microphone? Yes.
If you do a failover, do you have to do a complete resync of the database, or can you use something like PG Rewind?
No, PG Rewind doesn't really help you much because we need to read actual write-ahead logs, so I'm not sure how that would work. The main problem there is that the logical decoding actually doesn't follow the timeline switch. So when the timeline is bumped, the logical decoding can't go over that bump, and so you basically need to do resync, yes.
And the user used, is it any kind of super user, or has it to be the Postgres user?
I'm not sure what you mean.
The user used for the replication, for the Pglogical, must it be just any kind of super user, or must it be a specific?
No, it doesn't matter. You can specify it in the connection string, for example, or the normal PG pass authentication works. You just have to put it into Postgres home directory or something. It uses normal connection. All the connection parameters in Postgres are actually supported. So.
Cool, thanks.
Okay.
More questions?
Yes, it's same license, and we actually gave the copyright to PostgreSQL Global Development Group, so we don't even hold copyright on it ourselves.
So, thank you very much, Petr.
Thanks.